So again, up at the top was just sort of a formalized mathematical version of what I just said, is that if you multiply x by some number, then y gets multiplied by that same number, but raised to whatever power was in your variation equation, okay? So if it's an x squared equation and I multiply by 5, your end result, or your y, gets multiplied by 25, okay? Because 5 squared is 25. All right, so let's take a look at example 1. In a parade, the height of a float varies directly with the square of the length of the vehicle. So again, there's that key sentence. Remember how we always kind of look for that key sentence? The weight varies directly with the square of the length. So before we go any further with that, let's just take that sentence and translate it into a variation equation, a general variation equation. What's that going to look like? Drew? Okay, y equals kx squared. Yep. And we could have also used like h and l instead of y and x. All right, it doesn't really matter, but just so we have an idea of what we're working with. Okay, so this here, the vehicles, all right, and the x represents the length of the vehicles. The vehicles are 3 times as long. So I'm taking this x value and multiplying it by 3. Okay? So how many times larger is the height going to get? That's what this question's asking me. Emily?
6 times as big.
Really close. Where are you getting 6 from?
The square.
Okay. You've absolutely got the right idea, but careful. 3 squared is 9, not 6. Okay? So if I multiply by 3 over here, I'm going to multiply by 3 squared over here, which is equal to 9. So it's going to be 9 times as tall. So notice it's not actually asking you to find, like, what will the height be. It just, I can't write and talk at the same time. I apologize. It's just asking what effect, what will happen to that height. If I take the length of the vehicles and triple them, then I can make my floats 9 times taller. That's pretty huge. Good? Does that make sense? Okay. So example 2. The weight of a land animal varies directly with the cube of its femur diameter. Do you know what a femur is? Anatomy people? It's like your thigh bone. Okay, so it's like the length of your like big thigh bone. I think they said that's, I was going to say it's the biggest bone and it's definitely the most dense, hardest to break. If you see somebody who broke their femur, oh my goodness, that is quite a feat. Okay, so again, let's focus in on our key sentence. The weight varies directly with the cube of the femur diameter. Okay? So again, before I care about anything else in the problem, what's our general equation look like here?
Y equals k times x cubed.
Perfect. Y equals k times x cubed. Okay. Phoberomus, I have no idea if that's how you say that, is a rodent that's extinct, and its femur diameter is 18 times that of an average guinea pig. Okay, so it's similar to a guinea pig, but the femur is 18 times larger. Okay? So if the femur is 18 times larger, what's going to happen to my y value? Okay, it's going to be multiplied by 18 to the third, which, gosh, I don't even know what that is. 5,832? Yeah. So that's 5,832 times bigger. Okay? So the weight of this animal is 5,000, almost 6,000 times that of a guinea pig. Does that terrify anybody? Like, I'm trying to picture what this thing looks like. It's kind of terrifying to me. Okay, right now, an average guinea pig weighs 2 pounds. So this one does ask me to take the extra step and actually do a calculation. So right now, the average guinea pig weighs 2 pounds. What would I do with that to figure out the weight of this guy? Yeah, so let's do 2 times 5,832. It's going to be in the 12,000 range.
11,664.
Thank you. So this is the weight of one of these animals. So see how I did that? I kind of figured out what would the overall effect on the weight be, And then I just applied that effect to the 2 pounds. Is that making sense? Yeah, good. Still no? Am I seeing some head shakes? You want me to talk through it again? So I started with my general variation, okay, which is the same as we've been doing. Just make sure you're paying attention because now I'm starting to mix them up on you. If it's direct or inverse, okay? I took this sentence, translated it into a general equation, and then remember, whatever you do to the x value, that same thing happens to the y value, but you have to include that exponent. So I included the exponent and said, okay, if this is multiplied by 18, this gets multiplied by 18 cubed, which apparently is this giant number. And then it actually tells me, right now a guinea pig weighs 2 pounds. All right, so a 2 pound, now I don't know what the femur length of a guinea pig is, all right, or femur diameter, but I do know that the weight is 2 pounds, and I know that this is how the weight would compare with an average guinea pig, so that's why I multiplied it. Good? Okay. Let's try some of these on the back. So example 3, we worked with this formula in one of our homework problems yesterday. I equals k divided by d squared. Now, here's that magic sentence again. Intensity of light varies inversely as the square of the distance. But notice they already kind of set that up for you. So you don't even have to worry about it. K divided by d squared. Okay? You are working on homework sitting at your desk, and you decide your desk is too uncomfortable, so you move to your bed. But your bed is 3 times as far away from your light as the desk was. So when you move, you're tripling the distance between you and the light. And I want to know, how will that affect the intensity of the light? Now, it doesn't actually tell me the intensity, so I don't have to calculate anything. I just want to know what's going to happen to the intensity. Okay, so this time, if I triple the distance, if I multiply this by 3, what's going to happen over here?
Gonna divide by 9.
Okay, because it's inverse, this time I'm doing division, and I never write my division this way, but I think in this case it's going to make the most sense. So if I'm multiplying by 3 over here, I'm dividing over here because it's inverse. And because of that square, this would actually be 3 squared. Okay? So you could say this in a couple of different ways. You could say the intensity would be 1/9 of the original intensity, something like that. You could say it's 9 times smaller. You could say it gets divided by 9. But I want something that tells me that it's getting smaller because I'm dividing by it. Okay? So you could say 9 times smaller or lower. I'm not really sure how you talk about intensity, but you could say it's that the intensity is divided by 9. However you want to word that. As long as it's clear in your answer that it's not being multiplied by 9. That it's not 9 times bigger, it's actually 9 times smaller. Do you follow that one okay?
So that's a 1 in front of the equal sign?
No, that's an I, I'm sorry. That's the intensity. Okay, so what I'm saying is the effect on the intensity will be, it'll be divided by 9. Okay, which dividing by 9 is the same thing as multiplying by 1 over 9. Okay, it's the same idea. Good with that one? All right, let's look at our law of the lever again. Once again, they give you that general equation. You sit on one side of a seesaw and you're trying to balance with that seesaw with a child who weighs half as much as you do. Okay? How would you determine how far away from the fulcrum the child should sit? So again, I'm not actually asking you to calculate because I'm not giving you like the child weighs this and you weigh this. I'm just telling you the relationship between the two. So here's my general equation. What effect are we having? What are we doing here? Like up here, I was multiplying my distance by 3.
Dividing by 3.
Okay. you could think of it as dividing by 2 or you're multiplying by 1/2. I'm going to stick with multiplication right now, but you're absolutely right that division is an okay way to think about it. If I'm multiplying by 1/2 over here, what's happening over here? Dividing by 1/2. Now let me ask you this. What is dividing by 1/2 really doing? Multiplying by 2, yeah. Dividing by a fraction is the same as multiplying by the reciprocal. So just like Selena was just saying, when we multiplied by 1/2 over here, that was really the same as dividing by 2, right? And dividing by 1/2 over here is really the same as multiplying by 2. Okay, so either one of those would be okay. Does that make sense? So how would I determine it? The child would need to sit what in comparison to where I'm sitting? Twice as far. Yep. So however far away you are sitting from the center, the child would sit twice as far. And that would be a rule of thumb you could use for any person that sits down. So again, I don't care what your weight actually is. If a child sits down that is half of your weight, they need to sit twice as far away from the center. Does that make sense? Are those feeling better now? A little bit, I hope. Yeah. Okay. Okay, let me get this stopped here.